Welcome to episode 1 of Object-Oriented Programming with Python series, where we'll explore the foundational concepts of object-oriented programming in Python. If you're new to Python, I'll highly recommend checking out my 14-day Python Beginners course playlist. This comprehensive series is designed to take you from a computer beginner to a confident Python programmer in just 14 days. Each episode covers essential Python topics from installing Python to mastering file handling and everything in between. You'll find the link in the playlist in the card as well as in the description and comment section. In Python, everything is an object and each object has a specific type. Python supports many types of data including integers, float, strings, list, and dictionary. Each of this type is represented internally as an object with its own data and behavior. Each data object has an internal data representation, the data that object holds, whether it's a primary type like an integer or a composite type like a dictionary. And each data object has procedures for interactions. These procedures are a set of operations or method that allows us to interact with the object. So overall, object-oriented programming is a programming paradigm that organizes the code into objects which combine data and the operations that can be performed on that data. I'm going to repeat once again the key concept of object-oriented programming in Python is that everything in Python is an object. Every value from single number to more complex structure like list, custom classes is treated as an object in Python. You can create new objects like creating a new int object or a list, or manipulate the object by appending or adding item to a list, or destroy an object by either using delete or allowing Python's garbage collector to reclaim memory. An object captures internal representation of data that objects holds via attributes. An interface for interaction, the way we interact with object via method. This abstraction allows us to use objects without needing to know how they are implemented. For example, internally, list is represented in a specific way, but as a user, we don't need to worry about this internal representation. Instead, we use methods and functions to interact with the list. Let's define a list of number, and to interact with this list, we'll use function like accessing the element of the list and printing it, adding an element to the list, getting the length of the list and printing it, and removing an element from the list. We'll run this and we can see the second element we have printed, which is at index 1, is 2. We can appended one element to the list, so the length of list has now increased, and then we have popped the item from the list. So the actual representation is hidden, and manipulating it directly could break the object. So we don't know whether a list is implemented as a contiguous array or a dynamic array or as doubly linked list or a single linked list internally. And we don't need to worry about these internal representation. Instead, we are using these methods and function to interact with the list. So the actual internal representation is hidden, and manipulating it directly could break the object. This is the key important aspect of the object-oriented programming. So to define an object in Python, we first need to define class. So to define a class in Python, we need to use class keyword and the class name. The class name should follow the naming convention of camel case, which means capitalizing the first letter of each word. The general syntax of defining the class is class name, colon, and then the block of code which will define the class, which is indented inside the class definition. So let's see how to define a class in Python. So we'll define a class car. So the first thing is we'll define _init_method, def _init_. So we can see self object is automatically passed by the editor and refer to the instance being created. To define a class for a car, we should have make of the car, its model name, and the year in which it's being made. So the make, model, and year are the attribute of the class car. And we have to initialize these attribute inside _init_method. To access the attributes inside a class function, we'll use self, which is the object instance, make, assign make, self.model, assign to model, and self.year is assigned to year. So over here, we have defined a class car. The init method is a constructor-like method which is called when a new object of car is created. It takes 4 parameters. Self, this is automatically passed and refers to the instance being created when calling the Python method. When calling a method, you don't have to pass self. Python does automatically for you. Make of the car, for example, it's a Toyota or a Honda or a Hyundai. Model of the car, such as Corolla or Civic, and the year in which it was manufactured. So in this code, the constructor initializes 3 attributes: make, model, and year for each car objects. Once again, this init method is a special method and it's called a constructor, which initializes the object's attributes, and it can take multiple arguments, with the first argument self always referring to the instance being created. Now let's create some car objects. My car, let's say Toyota, model Corolla, built in 2024. Your car, again initialized by calling the car constructor. Honda, model Civic, in the year 2022. So we have created 2 objects, my car with attributes Toyota, Corolla, and 2024, and your car with attributes Honda, Civic, and 2022. Each object is an instance of car class, and we have created 2 car objects. So over here, these 2 car objects are instance of car class but have different set of attributes value, which distinguishes them from each other. And attributes are like variables attached to each object. We can access and modify them using dot notation. So if I say my car dot make and print it, it will print Toyota. I can change the manufacturing year of your car also. Your car dot year is not 2022 but 2023. And then if I print your car dot year and we run it, it will print 2023. So basically this code is showing that we can access and modify the attributes of car objects using dot keyword. Now we have defined the basic car object with attributes, but object should have some functionality also. Next step is to define and use methods in car class. Methods are basically function defined within a class that describes the behavior of the object. So let's add a method inside the car class. We'll define it as drive. The editor is automatically adding self in the parameter. Let's pass in a parameter distance, which will be traveled by car. So we'll define one more new attribute called odometer inside our class definition, and we initialize it to 0. Because when we are buying or creating a new car object, it has not been driven and its odometer is set to 0. Now whenever we drive a car with certain amount of distance, its odometer will get incremented by the distance, and we can print a message in an F string that the self.make, self.model has driven distance in kilometer, and total distance traveled is the value of the odometer attribute in kilometer. Now we can use this method for driving my car by calling drive method with value 100 and then again stopping and then driving again 50 kilometer. Oops, I got an error because this should be self.me, and now I run it. So we can see that the first output is saying that Toyota Corolla has driven 100 kilometers. So total distance travel on the odometer is 100 kilometer. Then again, it has driven 50 kilometer and total distance is 150 kilometer. So in Python, you don't need to manually delete objects when you're done with them. Python has an automatic garbage collection which reclaims memory for objects that are no longer in use or accessible. Unlike languages in C++, Python doesn't require explicit destructors because its garbage collector handles memory cleanup automatically. So I have introduced you to the basic concept of class in Python, which is basically a blueprint to define objects and its attribute and how to modify the attributes using the methods in the class definition. So let's do a hands-on exercise by building a simple library system which will help us to enforce our concepts of classes and objects in Python. So library has collection of books, and a simple library management system is a way of organizing books and managing the books. So first we have to define a book class. Class book. So first we'll define the constructor def _init _ self has been automatically passed by the editor. What kind of an attribute a book object should have? It should definitely have a title, author, and a unique code to identify that book, which can be an ISBN number. So now we'll initialize all these attributes in Python. Self.author is author, self.isbn is ISBN, and we'll define its current status, whether it's in the library or it's with some user who has borrowed the book from library. So we will define this as is borrowed, and initially we'll assign it to false. Now we have defined the basic constructor. We'll define two basic methods which can be used to modify the attributes of class. So in the library management system, you can borrow a book or you can return a book as a member of that library. So we'll define first borrow. So what should be the condition? If not, self dot is borrowed is true, means that book is in library. We'll assign self dot is borrowed true, and then we'll return true. What if the book is not in the library because someone has borrowed it? It means that is borrowed is already true, which means I cannot borrow this book again. So I'll return false. Similarly, if someone is coming to return the book, we'll define a function return book self, and the only thing we have to change is its status of the is borrowed variable to false. So just to recap, the book class has a constructor that initializes title, author, and ISBN and is borrowed attribute, a borrow method that checks if book is available, which means not borrowed. If available, it marks it as borrowed and returns true. Else, if it's already borrowed, returns false. It's also having a method return book that marks the book that is not borrowed. Now let's create another class named library, and in this class we'll first again define _init _ constructor function, and inside this constructor, when the library object is first being created, we'll define it as a collection of books. Collection of books can be a list, so we'll define self.books as an empty list. So this is the basic definition of our library constructor. Now we'll define a method to add a book to the library. So we'll pass book parameter, and then we'll have to just append this book in the books list. So this method will add books to libraries. Now if I want to display a book about the status of the book, whether it's borrowed or it's available. So if someone comes and asks that whether this book is available and is it not borrowed by someone else, so we'll define a function called display book. It's a basic function which will just look for a book in all the books list, and then we'll assign a status string borrowed if book dot is borrowed else available. So over here you'll see we have used a special one-line if-else construct to assign status string borrowed or available based on the condition of if book is borrowed, true or false. This is a special one-line if-else construct that I've used to showcase the capability of Python. Now I can print using f-string. We can say book.title by, again braces, book.author with ISBN number, book ISBN bracket close status. So this will display all the books available in the library. Now, bit complex method is to borrow a book. So we'll define it. Borrow book. We'll use the ISBN number, which is a unique identifier. Again, we'll do search for book in self.books. It's a basic, pretty simple search functionality, rudimentary search functionality. For each book in the collection of books, if the book ISBN number matches with the ISBN number that has been requested by the customer, then we'll call borrow. But again, in borrow, we can have that whether book is available or somebody has taken it. So we'll check if book.borrow is true, then print f-string successfully borrowed book.title. Else, if book.borrow method returns false, we'll print f-string, sorry, this book is already borrowed, and then we'll return. Now, if the for loop has run and we didn't find the ISBN matching with the list of ISBN that are there in the library, we'll just print book not found in the library. Now, we have displayed the book, we have added the book, we have borrowed the book. Now, as a library member, before the due timeline, I have to return the book also. There can be another method for this library management system is to return the book, which will again has ISBN as a parameter. Again, we'll do simple search for book in self.books. Again, I'll copy this line. If book.isbn is equal to ISBN, then we'll just have to return book, and we can print an output to the console that successfully returned the book with title book.title, and will return. But what if this book is not the part of the library? We'll again print this book doesn't belong to our library. That's it. So just let's check and review the library class. So the library class is basically managing a collection of books. It has books list to store book object. It has add book method that appends a book to the books list. Display book prints the information about all the books in the library. Borrow books find the book by ISBN and attempts to borrow it. Return book finds a book by ISBN and mark it as returned. So now we have created a simple library management system, and let's start using our system. So first we'll create an object of library class, my library. Then we'll add some books in library. First book is Python Crash Course by Eric Math and its ISBN number. The second book is Clean Code by Robert C. Martin with ISBN number. And the third book is The Pragmatic Programmer by Andrew Hunt with ISBN number. Now we'll try to run the program that we have written to check if there's an error or not. We run it. So till now there are no errors. Now let's display all books by printing first a library catalog header, and then I'll call my library.display book. We run it. So on the console, I can see all the books available in the library management system. So this function display book should not be display books, but rather display books. I'll just rename it by refactoring it. That's it. Okay, so now I'll try to borrow a books from my library object. I'll call borrow book with ISBN number, let's say Python Crash Course once, and I'll run it. It's giving error, book, the same silly mistake, book.title in borrow. So I should be using the dot. Okay, now I'll run it again. So I have successfully borrowed the Python Crash Course book. Now let's try to borrow the same book again, the same book again. And when we run it, so it's calling the function and we are getting the message, sorry, this book is already borrowed. Now what should I do? I have read the book and now I'm planning to return the book. So I go to the library and return the book. So my library dot return book with the ISBN number Pragmatic Programmer. And now if I run it, I have successfully returned the book. So in between, if somebody asks for list of available books in the library, I can call my library dot display books, and then we run it. We can see that initially we had 3 books which were available. Then I borrowed Crash Course. Then again tried to borrow, which it didn't allow. Then I displayed the available book, and the Python Crash Course book is not available. And then if I try to call this method again, we can see that all books are available now. So this exercise demonstrates how we can use classes and objects to model real-world scenarios. So we have created a book class to represent individual books and a library class to manage a collection of books. The library class had methods to add books, display book, and borrowing and returning the book. This concludes our session for today. We have learned the basic of object-oriented programming with Python. In the next episode, we'll learn about inheritance and polymorphism. If you have any questions or feedback, please let me know in the comments below. Thanks for tuning into Sumanth Codes, and if you found this helpful, give it a thumbs up and subscribe for more coding tutorials. Hit the notification bell too, and let's continue this coding journey together. Stay tuned.